Welcome to our webinar session, Reinventing the Building Sector. It's the second webinar within our series of events, and we are very happy that again, some outstanding architects' offices followed our invitation to present some of their projects here. For those of you who couldn't join us in our last webinar 2 weeks ago, my name is Christiane Kretschmer and I am part of the Rebau project team, which hosts this event. Some technical information first. As mentioned before, we are recording this webinar and it will be published on our YouTube channel afterwards. So if you do not like to be pictured, please turn off your camera in the whole event. To avoid background noises, we would also like to ask you to mute yourself. In our last webinar 2 weeks ago, we focused on the topic of renewable building materials. And today we will switch to another, though equally important focus, which is the topic of circular economy and the reuse of building materials. So our built environment, it's increasingly seen as source of secondary raw materials, which can be reused and then bring to life new constructions. And in this sphere, there is a great potential which can be used. And in our webinar today, we will learn about 3 buildings whose planners took note of this potential and consequently put it into practice. Concerning our program today, our project leader, Magdalena Zabek, will now give you an overview on today's topic. Afterwards, we will listen to 3 presentations of the respective architects, each 15 to 20 minutes, which will be in English. We will provide you with a German transcript, so you can check your chat window, and there we will post shortly before the beginning of the presentations, we will post the single transcripts for you. At the end, everyone can ask questions and participate, and we will have time for a common discussion round. So now I'll hand over to Magdalena and for her presentation.
Thank you, Christiane. So I also like to welcome everybody, all our guests and listeners. And the last time I talked about the Rebau project more in detail, and today I'd like to talk about the circular economy. I do that in English, and I hope that's okay for our guests. Ja, auch von mir ein herzliches Willkommen heute zu unserer zweiten Webinarreihe. Die Webinarreihe findet statt im Rahmen des Rebau-Projektes und das Rebau-Projekt steht kurz für die regionale Ressourcenwende in der Bauwirtschaft. Das Projekt ist Anfang letzten Jahres gestartet, geht über 3 Jahre und in den Zeitraum haben wir einige Aktivitäten vor, wie zum Beispiel die Gründung eines Kompetenzzentrums, die Etablierung von neuen Recyclingprodukten auf dem Markt, die Erstellung einer Rohstoffbörse, Förderung von Innovation im Baubereich und die Gestaltung einer ressourcenschonenden Siedlung. Das alles tun wir im Rheinischen Revier, was zwischen Aachen, Köln und Düsseldorf liegt und aktuell mit dem Strukturwandel zu tun hat. Und wir finden auch, dass auch in der Baubranche einiger Wandel vollziehen muss. Und deshalb werde ich heute ein wenig genauer über die Ressourcenwende sprechen. Ja, das Thema der Ressourcenknappheit ist kein neues Thema. Das Wissen ist vorhanden. Seit den 70er Jahren ist es auch in das Bewusstsein der breiteren Masse getreten, dadurch, dass man den Planeten das erste Mal als Ganzes gesehen hat mit der Apollo 13 Mission Und daher ist es klar, dass die Erde ein energieoffenes, aber stofflich geschlossenes System ist. Was seitdem passiert ist, dass wir unseren Ressourcenverbrauch gesteigert haben. Der liegt aktuell so, dass wir am besten gleich 3 Planeten bräuchten, um ihn zu stillen. Das haben wir nicht. Aber in der Baubranche waren wir nicht ganz untätig. Seit den 70er Jahren gibt es die Energieeinsparverordnung, die es geschafft hat, den Energieverbrauch in der Nutzungsphase von Gebäuden zu reduzieren. Gleichzeitig sind wir mittlerweile imstande, mehr Energie zu produzieren, als wir verbrauchen in der Nutzungszeit durch die Herstellung von Plusenergiehäusern. Was wir dabei vergessen haben, ist die Energie, die wir verbrauchen für die Herstellung dieser Materialien und die Ressourcen. Und ein weiterer Aspekt, den wir auch außer Acht gelassen haben, ist, was danach passiert, nach dem Lebensende eines Gebäudes. Aktuell sieht die Baubranche so aus, dass sie 60% des globalen Abfalls produziert und auch 40% der Ressourcen verbraucht. Und gleichzeitig ist die Bauindustrie verantwortlich für 33% der CO2-Emissionen. Das heißt, dass wir immer mehr Ressourcen verbrauchen und gleichzeitig auch Müll produzieren. Und was stattfinden müsste, ist, dass wir Müll als Ressource sehen, dass wir anfangen, Gebäude als urbane Minen zu verwenden und am besten gar nicht Müll produzieren lassen. Wie wir das machen können, ist, indem wir die Circular Economy umsetzen. Auf Deutsch kann man das übersetzen auf das Wort zirkuläre Wertschöpfung. Was damit gemeint ist, ist, dass ein hochwertiges Recycling hier in den Fokus tritt, bestenfalls eine Wiederverwendung von Materialien. Und gleichzeitig werden Produkte schon so hergestellt, dass man sie am Ende zerlegen kann und wieder in den Materialkreislauf zurückführen kann. Und einige Branchen haben das schon gut umgesetzt, wie zum Beispiel die Autobranche. Beim Bauen sieht es so aus, dass wir durch die Circular Economy der Ressourcenwende ein Stück näher kommen. Dabei haben die Architekten eine besondere Rolle, da sie verantwortlich sind für die Materialwahl und auch die Konstruktionswahl. Was man dabei beachten muss, ist, dass man ganzheitlich denkt und handelt. Das heißt im Sinne der Circular Economy den ganzen Lebenszyklus eines Gebäudes in den Blick nehmen. Das heißt, über die Bauphase und die Nutzungsphase müsste man sich den Rückbau und die Produktion von Produkten anschauen. Das rückt einige Aspekte in die Planung mit ein, wie zum Beispiel Bauen mit nachwachsenden Rohstoffen, wie zum Beispiel Holz. Und diese können nämlich nicht besonders umweltschonende Produkte bzw. CO2-produzierende Stoffe wie Beton ersetzen. Ein weiterer Aspekt ist die Verwendung von wiederverwendeten oder wiederverwerteten Materialien. Nämlich die können primäre natürliche Rohstoffe einsparen und somit schonen. Und ein anderer Aspekt, der auch wichtig ist bei der Planung einer ressourcenschonenden Architektur, ist Bauen nach Kreislaufprinzipien. Ein sogenanntes Disassembly kann an Anfang an bei der Produktherstellung und bei der Konstruktion eine spätere Müllentstehung vermeiden. Und aktuell sieht es so aus, dass Gebäude nur 1% der Gebäude rückbaufähig konstruiert sind. Wir widmen uns dem Thema in der nächsten Webinarreihe. Da gehen wir genauer darauf ein. Da werden wir auch wieder 3 Gebäude sehen, die nach den Prinzipien entworfen sind. Und heute freuen wir uns über 3 Best-Practice-Gebäude, die sich dem Thema der Wiederverwendung wenden. Somit übergebe ich an meine Kollegin und wir sehen uns später noch bei der Diskussionsrunde. Thanks for your attention and I'm looking forward to this very exciting presentation of yours and I see you later at the Q&A session. Thank you.
Yeah, thank you, Magdalena. We will now directly start with the architects' presentations, and I'm happy to introduce you to our first speaker, Marc Maurer from Maurer United Architects, who presents the Superlocal project. So Marc, if you want, you can start now sharing your screen. Maurer United Architects was founded by Marc and Nicole Maurer 23 years ago, and their cooperation is based on a common attitude. As architects, they want to work interdisciplinary for an audience as wide as possible. They realized projects in the Netherlands, Belgium, Germany, and China, and developed a wide and multidisciplinary portfolio of projects. Their project Superlocal in Kerkrade in the south of the Netherlands is a showcase and a research laboratory for building material recycling. The fundamental question behind the project is it possible to reuse at least 90% of the building materials of 3 demolished high-rise buildings to build over 100 modern flats on site that meet current standards? So we're curious about your answers, Marc, and about your presentation.
Well, thank you for the very nice introduction. You said that we built or realized buildings in the Netherlands and abroad, and I'm very happy to say that we also realized a building in the Rheinische Rivier, which is the Indeman at Indeland. And so we are very happy to present today in the Rheinische Rivier again. Well, I will tell you about the project Superlocal. It's an innovative project in which 4 apartment blocks and their surroundings are being transformed circularly into a new sustainable living environment in Kerkrade. The project was started by Heemwonen and the municipality of Kerkrade in connection with the demographic changes resulting into an integrated restructuring task for the Parkstad-Limburg region. The project owners formulated the joint goal of building 125 social housing units with the exceptional ambition to use only material of the existing to be demolished flats, which in total count 400 apartments, for the construction of the new houses. Superlocal is a project for the International Bouwausstellung IBA Parkstad-Limburg 2021. These graphs show how social thinking and acting has evolved over the past centuries. Coming from fairly stable linear growth in the past, the growth has risen to an expansional dimension during the industrialization age, and which is not very sustainable. Now the people try to turn this exponential growth into a circular stability and a new balance. However, this means that after years of modern thinking, always promising the better future, we are now definitely landed in the future. But let's start with the past of the project location, Kerkrade in the south of Dutch Limburg. The origins of Kerkrade can be found in the Rol Duc Abbey. The writings of the abbey mention coal mining already in the year of 1113, the first mention of coal mining in the whole of Europe. During the formation of the Kingdom of the Netherlands in 1815, the local abbey mine was transferred to the ownership of the new kingdom and was given the name Dominare. Bleijerheide, the project location, is located in the southeast of Kerkrade on the German border with Aachen. In 1907, the Dominare built the Newland shaft, which you can see here on this picture. The iconic shaft was directly ejected to the district of Bleijerheide and was an image decisive for the surroundings. After the closing of the Dutch state mines, announced in 1965, I know in the Rheinische Rivier it's 2038, the Newland shaft was decommissioned as the last part of the national mining industry. Today, it's one of the few structures that still refer directly to the mining area. The mining period has also brought a lot of welfare to the region. According to the English Garden City principle, several residential areas were built for the mine workers. These neighborhoods are still inclined today. Later, the economic growth ensured a modern attitude among citizens, entrepreneurs, and administrators, In the architecture, experiments were made with concrete structures, lots of glass and straight lines. On December 1965, Dutch Minister Den Uyl presented his note Mining Industry in Heerlen. The note stated that the decision was made to phase out the coal production while providing new employment for the mine workers, counting 45,000 direct jobs and a few tens of thousands more concerning supply companies. The practice turned out to be different. The closure operation went faster than expected, and at the end of 1974, the last mine closed and many inhabitants of the region became unemployed. However, after the closure of the mines, there was still a demographic growth due to the baby boom. Bleijerheide became a residential area, and 400 new dwellings, you can see them here, were developed in 1967. They were all identical apartments. The Social Housing Fund chose the modern systematic architecture of the high-rise flat buildings constructed by contractor Wilmabouw. From 1960 to 1975, approximately 12,000 of these system homes, we call it the gallery flat, were realized in North Brabant and Limburg. The architecture is related to well-known examples such as the English Park Hill in Sheffield and the Bijlmermeer in Amsterdam. The construction method expressed society's desire for a new modern age. The homes were mainly made available to families with a good income. Kerkrade and Bleijerheide flourished during this time. There were many shops and pubs in the area. The families were very close. Children played outside in the green, and parents were active in one or more of the many community clubs. This went well for 25 years. After that, several social changes took place. Families got smaller, increasing single parents, a lot of unemployment. The practice of the social housing changed and residents felt less involved. The social networks and amenities disappeared over the time. In addition, the architectural condition of the flats deteriorated considerably. Concrete parts were falling off due to the rusty reinforcement. The galleries and balconies on the flat had to be propped up at some point. The decision was taken to demolish 4 flats, counting 100 apartments each. This was a responsible choice, partly due to the fact that there was no population growth in Kerkrade anymore. For the first time, there was a serious demographic shrinkage, and therefore homes had to be withdrawn from the market. The first flat was demolished with the aim of building new but much fewer houses. This stirred emotions among the residents. They felt very connected to the flats. It became clear that the project needed to be handled more carefully. Perhaps it was better to find out which values could be retained. The social networks that still exist, for example, are very valuable. How could this be maintained? There was an ambition to recycle as many existing local values as possible, including materials. And so the title for the project was born, Superlocal. Mauro United Architects devised a circular process triangle for the Superlocal project based on the multi-annual phasing, with the initiative in 2014 and the planned completion in 2021. Instead of a fast, more and global approach, we chose a slow, less and local philosophy. Here you can see the different phases of the project, and we are now in the phase of creation, close to completion. The year 2021 is the presentation year of the International Bouwstelling Parkstad Limburg, and Superlocal was submitted as a project and eventually became a key project within the IBA. We started the project by making a thorough, precise inventory of all the values in the area. The former and partly remaining residents were interviewed. This allowed us to put together an evaluation of the archetype gallery flat in use during the period from 1968 to 2018. But many other indexations were also made, such as the construction materials, landscape, floor plans, and more. All these findings have been substantial influence in developing the new plans. In this way, the modernist archetype has been evaluated from the inside out. The findings were all summarized in the so-called neighbors book entitled Iedereen vult zich daarheen, which is Blijheid's dialect for everyone felt at home there. In the neighbor's book, the ideas of the apartment residents were bundled together so that these could be preserved. The values also formed an important input for the design of the new homes. The mapped social network is of value and will also be reused. The original residents of the flats will be offered the opportunity to come back to Blijheide after completion. Kirsten Hadema recently wrote about this approach by Marlborough United Architects in the Rijnbouw magazine. How can architects incorporate what is of cultural, emotional, and social value into the circular idea in order to make cities fully sustainable? It starts with the shift from the focus on the beta side of architecture, the material, to the soft side, the intangible heritage. In the Netherlands, we are increasingly working with existing neighborhoods and sedentary residents in the introduction of the participation society. They are asked to think alone. Circular demolition and construction is becoming increasingly important. In the long run, it will become impossible to keep extracting new raw materials from the earth. It is therefore that we increasingly try to find out how materials can be reused. The superlocal process was set up to conduct experiments in the fields of circular building. For example, concrete elements from the existing flat were sawn and relocated to investigate whether they could be reused. The demolition firm went so far as to cut out an entire building blocks with walls and floors and hoisted the crane out of the existing flat. This was actually revolutionary for the construction practice. As an experiment, a complete house was built from the harvested materials. The intention was to use only recycled elements from the flat. No new elements were allowed to be added. The aim of the experiment was to find out what problems would encounter. And there were many, particularly in the area of regulation rules. It became also clear that in subsequent circular buildings in the field of installations, insulation, and finishing materials will eventually have to be added. Today, the experimental building serves as an information pavilion for the project. The unique approach of superlocal was awarded by the Dutch Building Prize in 2019 already. In the meantime, the demolition firm has managed to regrind the concrete that is released from the demolition. This results into new mining hills on the demolition and construction site. The material is extracted from the existing flats. The concrete is mixed on site and used for construction of new infrastructure and homes. Kerkrade is pioneering here again as before. From the first coal mine in Europe, a long way has been traveled towards the first recycling concrete mine, an important step for the future. Different experimental building sites attract many visitors to the superlocal area. You can see some examples. There were a lot of gatherings at the Info Pavilion and also on the different demolition phases. All the knowledge gained from the superlocal project is used to realize new social housing. This is reflected in a new gallery flat on site. The flat has 140 dwellings. Instead of the 100 identical dwellings, it has been chosen to integrate different types of housing and amenities, allowing different target groups to be better served and creating a mix of residents. Different types of durability are also applied in the flat. Half of the flat has not been demolished, but stripped to its concrete structure. The construction is reused and provides for the structure of 50 new homes. Secondly, in the extension of the flat, concrete from the demolished flats was reused according to the principle of regrinding. And thirdly, applying new materials, the architectural details are constructed in such a way that they are reversible. A fine example is the brick facade of the plinth ground floor of the flat, which uses no mortar but is dry stacked. We chose to hold on to the building type gallery flat. We improved apartments in the existing structure according to the given input by the former residents from the neighbor's book. As mentioned, we also added new floor plans in the new building, in the new built half of the gallery flat. So types. As mentioned, we also added new floor plan. The galleries are situated on the north side at the ground floor of the left lower half of the flat. Instead of the usual storage rooms, social functions were planned, a place where inhabitants can meet and come together. This responds to the social change that has been taking place since 1968. Fewer families, but more need for social networking. In the plinth of the right half of the flat, terraced houses with own front doors were realized. All this gives the ground floor of the building a more lively character. On the west, apartments were planned that introduce a whole new view towards the municipalities of Heerlen and Landgraaf. With its height, concept and position, the building forms a new icon for the Parkstad-Limburg region. Here you see some important buildings of Kerkrade, and the superlocal flat is just a new icon in the row. I want to end this presentation by summarizing the superlocal project in 5 steps. At first, the first apartment block was demolished in a traditional way, and we found out that this is not the right way to do this, because we want to get more the involvement of the former residents in the project. So the second apartment block was demolished in an innovative and daring way. The cut-out segments were moved to another spot on the superlocal area, and the pavilion of 100% reused materials was realized. The third apartment block was demolished in another way. The concrete was shredded on site for producing new concrete. And then 3 + 15 new experimental houses were built. Different circular building methods were tested. Half of the fourth apartment block was demolished, the other half was stripped. The different tested techniques will all be applied in the realization of the redeveloped gallery flat. In total, 400 social housing units were reduced to 130 new housing units. To finish the superlocal project, all the water in the area will be collected and cleaned and reused as well on site. The United Nations Global Goals 2030 call for local targets. In Kerkrade, we have tackled this in a superlocal way. With the help of social research and technological innovation, a number of these objectives are met to the maximum. The project is now in the realization phase and will be put into use during the IBA exhibition year 2021. Thank you very much.
Thank you very much, Mark.
You're welcome.
Yeah, I think it's really an exciting project, and it really shows that besides the development of new technologies, it's also of great importance that the construction site logistics is considered, and we will be able to know more about it later on when it's time for questions from the audience. Our next speaker is Joost de Krieger from Superuse, who is presenting 2 buildings, the Villa Welpelo in Enschede and the Kringloopzuid in Maastricht. Joost de Krieger is a specialist in urban installations, focusing particularly on innovative architecture made from leftover and waste materials. His manifold work will arise from being the creative director of the Festival of Transitional Architecture in Christchurch, New Zealand in 2016, holding design workshops and being partner of the pioneering architect's office Superuse since 15 years. Superuse is formerly known as 2012 Architekten, and they have branches in 2 different countries with a headquarters based in Rotterdam. They are known for pushing the boundaries of architecture beyond traditional building methods into cyclical processes. Furthermore, they provide open source methods and tools to the design community. the way in which Superused chose the kind of materials for their building, Villa Velpolo in Enschede in 2008, shows how much they think outside of the box. As Joost de Krieger said in an earlier interview, they went around the city on bikes to the harbor and industrial places, going to factories and asking what kind of waste they produce. Then they mapped it and put it in a spreadsheet and made a type of shopping list that asked, what are the elements that we want to have for this project? And then they try to find them. The second building that Joost de Krieger will present is the Kringloop Zuid, which is a recycling center in Maastricht, which proves that it is actually possible for a business to realize its sustainable design and architectural ambitions at no extra costs. So I would like to ask you now, Joost, to share your screen and start your presentation.
Okay, I think this should be all set. Thanks for the introduction. Hello, everyone. I'm glad to see you all tonight in this digital environment. Tonight I will show you two of our projects, as mentioned, Villa Velpolo and Kringloop Zuid. But I'll start with a quick introduction of myself and our office. Growing up, I knew I wanted to be an architect. I was fascinated by the ancient monuments and the modern skyscrapers that were on the cover of my exercise books in elementary school. When I started studying architecture, this was still my dream, to create monumental buildings and skyscrapers. During my studies, I learned about sustainability and that there's quite a lot of building production around us that isn't necessarily good for the planet. Luckily, I discovered a small Dutch architecture practice with an untraditional take on architecture, which could teach me things that I could learn nowhere else. I started an internship there almost 15 years ago, and currently I'm one of the 4 partners of the firm. Together with our team, we are still learning and loving what we do on a daily basis. I hope I can inspire you to embrace our kind of architecture. Besides our office in Rotterdam and Amsterdam, we have an office in Beijing, China, and one of the founders, Cesar Perin, started Superuse on site to work on projects in close collaboration with the client. At Superuse, we design and develop on available surplus, reusable materials and waste. Superuse builds and designs innovative, aesthetic and inspiring environments, buildings and interiors. We create value by creating quality architecture while preventing the destruction of resources. Do you have any idea what these kids are playing in? This is the inside of a windmill blade that we used in one of our playgrounds. Our approach results in a smaller footprint in comparison to a regular building process and shortens and optimizes the flow in material cycles. In this case, the carbon emissions are reduced by more than 90%. The picture was taken inside the long blade in a playground in Rotterdam, made out of 5 rotor blades. I'm not going to elaborate on this, maybe another time. Today I will show our philosophy to you by taking you on a digital field trip to 2 of our projects located along the German border. Villa Velpolo in Enschede and Kringloop Zuid in Maastricht. I hope you will be able to visit these buildings soon, but for now I'll take this opportunity to show some things that a physical visit cannot offer. First of all, Villa Velpolo, a modern house for an art collecting couple. Villa Velpolo is located on the north side of Enschede, which is actually the city in which I grew up. The neighborhood where the villa is located was struck by a disaster in 2000 when a fireworks factory exploded. The urban plan of Pieter Bruin provided space for the old inhabitants, which was mostly working class, but also new plots for people that wanted to build their own house. The clients acquired one of these sites and approached Jan Jongert of 2012 Architects, now called Superuse, to design a house out of waste materials. This is what you see when you go to the house today. The outside doesn't reveal in any way that roughly 60% of the materials that are used would have ended up in landfill or incineration plants. Let's take a closer look at some of these materials. I'll show you where they come from and how they are used to create our kind of architecture. It is a modern house with big glass surfaces. On a sunny day, the inhabitants can close their curtains to prevent the house from heating up too much. But these curtains are not normally found in regular houses. They are more common in glass houses, where they filter the light to protect the plants. The north side of the house is relatively closed to prevent heat loss and contains most of the storage areas, like the garage. On the upper floor, the long closed wall on this side is one big bookshelf. The The top floor has 2 bedrooms, each with a bathroom. Laundry has to be done in the basement, so a clothing shaft connects the top floor to the ground floor. You can throw your dirty clothes in here and they end up next to your washing machine. When you take the stair in the morning, you end up in the kitchen and working area. That's where we go now. All fixed furniture has been custom made and has been designed mostly out of waste materials. These desks provide plenty of space and the windows facing southwest give daylight for sewing and other hobbies. In the kitchen, the origin of the material is visible. Let's take a closer look. All wooden cabinets are made from building advertisement boards. This is waterproof multiplex and usually has been standing outside for months, but becomes redundant when a project is finished. We harvested these multiplex sheets and collected them for the furniture maker. Going down the steps takes you to the living room and gallery. The owners love to support young artists by collecting their work and showing it in their living room, which sometimes doubles as a gallery for semi-private showings. The door that leads to the room in front of you is the guest room, located on the ground floor, and it has its own exit outside. Even the structure of the spotlights for the artworks had a former life. They have been collected after a storm from discarded umbrellas. Let's take a closer look at the floor plans. You can see the ground floor on the left and the top floor on the right. It shows that all rooms have their own bathroom with toilet and shower, even the guest room. It's perfect for having your children or grandchildren over for a visit. It may seem that the bathrooms are hidden behind the closed facade, but there is some daylight. As you can see on the right, there is light coming through the facade. Some of the cable reel slats have been left out to add a window for daylight and natural ventilation. The bathroom next to the master bedroom is also made out of waste materials. It looks a little like black natural stone, but actually it is a panel made from plastic packaging by Smile Plastics. This pattern is called charcoal. In the front elevation, it is also clearly visible in the top floor that 4 windows are hidden behind the facade for the bathrooms. The harvest map is a visual representation of the search we made for reusable materials. In the harbor of Enschede, we found several sources that could provide potential building materials. One of the main finds was the cable reel factory in Haaksbergen, roughly 15 kilometers from the site. They provided all the wood for the facade cladding. The core of the cable reel has been harvested, while the wheels stay behind at the source as waste. They are usually too damaged in the process. The slats of the core are treated to increase the lifespan of the spruce. This is done with a process called platinizing, where the wood is heated up to 170 degrees Celsius to remove most of the liquids. Afterwards, it has to dry carefully before receiving another treatment that is similar to baking. In the detailing, we defined clear volumes where the cladding is going around all surfaces, using the cable reels that we found. Super using this wood, in comparison to new wood, saved over 90% on carbon emissions for the cladding. For the steel structure, we harvested an old textile machine. Enschede used to have a big textile industry until the 1970s. When the factories closed and production moved to other countries, the machines ended up at scrap iron companies. We managed to find one of these machines and have been able to make over 90% of the steel structure out of this machine. It's an interesting fact that in this area used to be a textile factory, and that after almost half a century, remnants of that industrial past end up in a private house like this. In the finished building, most of that history has been hidden by insulation, cladding and wall finishes, but the bracing is still visible in the finished house. As you can see here, it has been painted silver to illustrate the rich history that is behind the structure. Reusing the steel structure saved almost 90% on carbon emissions compared to a new structure. I'd like to show you a 2-minute video that Al Jazeera made in 2012, interviewing the owners of the house.
2012's most ambitious project to date is the Villa Velpelu, a temple to super use and the first project of its kind. But having a home built almost entirely out of waste didn't faze the clients.
Because they were very serious architects, and I thought there should come something beautiful out of it. The work of the carpenter, this wood, is all reused. Colorful.
So what, billboards that you would see just on the side of the road?
The whole house is made from an iron construction, and these are parts of an old textile machine.
Earlier, this area was famous for its textiles, fabrics. So a lot of textile machines are still there unused.
And they make it from the
cable.
Oh, yes.
From
the
the
cable
cable.
spools.
Yeah.
Now your neighbors, they're not talking. Ah, did you see her? She lives in a house made out of rubbish. Oh, my goodness.
I'm proud of it.
There must have been some problems along the way when you're building a house out of waste materials.
Of course there were some problems. The first day, let me be honest, the first day I came in the house, I thought, why didn't they paint this side from the cupboards? They see that it is renewed. They should have painted it.
Oh, from the billboard.
Yeah, from the billboards. And now I'm so happy that you see the real billboards.
Do you think it's possible that this new model of construction could become the norm?
Yeah.
Do you think it could?
If everybody turns a button in his mind, it is possible. You make your money from your product and you give back to the world your waste, but in a good way.
So far for Villa Welpelo, we have arrived at Kringloop Zuid, a thrift store made out of second-hand materials. As mentioned, Kringloop Zuid is a thrift store and recycling center in Maastricht, close to the border with Belgium. One of the most striking features of the building is harvested from a windmill. Since we've made the playground that I showed in the beginning, we have been looking for other ways to put this material to good use. The first thing that appears when approaching the building is a giant billboard made out of a second-hand rotor blade. The whole blade is 27 meters high and the name of the recycling center, Kringloop Zuid, is written on both sides. On the corner of the building, the blade is standing on the ground floor and piercing through a hole in the roof. Initially, we wanted to use the blade as a chimney to create a natural flow of air through the building for ventilation, but this has not been realized in the final building. The concept that we made was a gradual transition of services inside the store. In one corner, the goods are dropped and distributed to several workshops. In the workshop, the selection is made which clothes are shop-worthy and what goes to textile recycling. The same goes for furniture, appliances, and so forth. Finally, the inspected items are priced and end up in the shop. What we finally have been able to make functions in the same way, although it is a bit more modest in its graphic language. The building itself is a pretty simple rectangular box. In the front is plenty of parking space, and the bottom right corner with the rotor blade is the place where people can drop off their second-hand goods. As you can see here, most of the front facade is glazed. Visitors arrive at the entrance in the middle, marked by the tip of the rotor blade that shows opening hours and such. This facade is facing east and allows the morning sun to enter deep into the building to heat the inside air a little. The south side is also pretty open, while the north and west side are more closed. The back of the terrain has containers for the goods that do not make it to the shop and become waste. In the process of developing the building, we used a harvest map to gather the materials that we needed. While the structure is a simple steel structure, of course designed for disassembly, the materials for the facades are second-hand. After Villa Welpelo, we have developed a harvest map to a platform that is online, accessible to everyone. It is a marketplace for professional upcyclers. Recently, we have transferred ownership of the platform to New Horizon, who have urban mining as their core business. We still use the platform while we can focus more on our core business of architecture. Let's take a closer look at the material that we've used in Kringloop Zuid. We came across these metal profile sheets that are common in business districts like the one Kringloop Zuid is located. The factory usually produces more of one color than a buyer needs, so a perfect facade can be made. This overproduction can be up to 4,000 square meters per month, which provided us with the ability to select what would be perfect for us. After we've made a selection of the potential colors, we designed a pattern that has been presented to the local authorities for approval. This led to some minor changes, but the actual result stays very close to the design. Take a look, for example, at the facade on the left, where a piece of red metal sheet is going from the pavement to the roof. Beside it is a pattern of blue and white, finished with another red piece where the windows start. Due to the sizes available and removal of the brighter yellow and green tones, the pattern developed a bit, but the core idea of the red, blue and white still stands. When you zoom in on some details of the facade, you can see that there are minor flaws in the cladding. In a regular building project, these panels might be rejected, while we think that it adds to the richness of the facade that when looking closely, you can see that this material has had a previous life. On the other hand, we are still architects that want to make beautiful buildings. These minor flaws on reused materials should not take the overhand. So I'm happy that in a facade view like this, they are lost. And more important even, something functional like a door can be bought new and made to order in the right size and color to blend in with the rest of the facade. Besides the cladding, also all the window frames have been harvested. They come from a demolition project close by where buildings had to be torn down to be able to upgrade the highway. In that particular housing project, all the window frames had the same height, all around the building. So it was relatively easy to design a new facade with it. We only had to make sure that the sum of all the widths would be the same, since we wanted to create large glazed surfaces. Take a look at the window with 6 pieces of glass. Can you find it in the facade of Kringloop Zuid? So that is exactly what we did. All windows have been used in the same position as they were in the original building, only in 2 or 3 horizontal rows to get more light in. When we move to the inside, you can see that it works. The large glazed facade of reused window frames provides plenty of daylight. All the clothes that are for sale are on perfect display. Happy secondhand shopping. Thanks for listening. If there are any questions, I'm glad to answer them when we come to the FAQ of the lecture.
Yeah, thanks a lot, Jos, for sharing your insights into these 2 outstanding building projects with us. Yeah, I think those examples really show that if we consider our decisions regarding material use and the construction method and think in a more circular way, then we could actually make a real shift.
Yeah, thanks. Welcome to do so.
Sure. So our next speaker is Lieve Nys from Blaaf Architecten from Belgium. Blaaf Architecten was founded in 2003 by the 2 architects Bart van den Driesje and Lieve Nys, who run the office together as managing partners. Their explorative and researching attitude towards sustainable and circular design have given Blaaf the reputation of pioneers within the field of architecture and urban design in the Flanders region. Besides their series of experimental private houses, Blaaf are currently working on various urban development projects, co-housing projects, social housing projects, and public buildings. Blaaf were nominated for several prizes in the last years, like the EU Mies van der Rohe Award in 2011 and in 2013. And they recently received the 3rd prize of the German AIT Award in the category of single-family homes. Lieve Nys teaches in architecture design and design theory at the University of Ghent, Belgium, giving elective courses in brick design. He will introduce us now to the DNA House and explain why and how it became a key project for Blaaf.
Thank you. Okay, I hope I'm understandable and you can see the screen. Good evening to you all. Thank you for inviting Blaaf to Rebouw and thank you for tuning in. Thank you, Christian and Magdalena, for the introductions, and thank you, Mark and Jos, for your inspiring contributions. My name is Lieve Nys, and I'm here to share with you some experiences with the use of reclaimed building materials by means of our DNA House, which was completed 8 years ago already in 2013. Now, the fact that we are still talking about this house today, I believe, is somehow a stimulus to keep pioneering, but it also shows that architecture is a slow medium and that producing knowledge through practice takes time anyhow. I will also try to situate the importance of this DNA House for our approach on circular construction, which is of course about more than reusing bricks. Blaaf is turning 18 this year, so we will finally be grown-ups. Last year's Flanders Architectural Yearbook featured Blaaf in an article called The Researching Practice, which is a title with a double meaning. The searching practice, as in how we have always asked ourselves what our role as architects for society could be, and the researching practice, as in how we have always combined our engagement with intuition and research as the basic information system for our designs. Our research so far being mainly practice and education based. Construction waste is an important urgency in Belgium as much as in any other country. This is a screenshot from a video by the Interreg program called Facilitating the Circulation of Reclaimed Building Elements, based on research by, among others, the Brussels-based office Rotor. It states that Belgium produces over 21 million tons of construction waste each year, a number which is unfortunately still growing. It also states that in history, the economic feasibility of internalizing the cost of reclaiming materials has always been evident. It is only since the second half of the 20th century that we have started to grow bad habits. The growth of global consumerism and the shift from expensive materials and cheap labor to cheap materials and expensive labor have somehow led to the externalization of both the impact and the cost of materials and waste. Therefore, the importance of the life cycle analysis approach of construction materials is that it maps both internal and external costs and impact of construction materials, the so-called shadow price. In the lowlands, the Dutch NIBE classification of materials has been a forerunner for many years. Flanders has only recently developed a similar tool called Totem, which is currently being implemented. If we look at facade brick, according to NIBE, it is class 1C. To give you an idea, in comparison to that, facade cladding in FSC certified tropical wood, fiber cement, or metal are all in class 3 or 4. The main reason for the excellent performance of brick is, of course, the lifespan or durability of the material, but also in terms of the LCA shadow price. It's interesting to notice that brick has low water impact, low resource impact, low land use impact, low toxicity, low maintenance impact, and low waste impact. The downsides of brick are mainly situated in the production process, while of course the baking process in itself is energy consuming, and it stands for 50% of the CO2 release and for 80% of the total LCA shadow price. But there are other factors that we can easily pay attention to. In the green box, there's the excavation and transportation of non-local resources for economic or aesthetic reasons. For instance, nowadays, white brickwork is highly fashionable in Flanders, but since we don't have white baking clay in our region, the only option is to import it. In the blue box, during the preparation of clay, it is often mixed with all sorts of additives to enhance the coloring or the consistency of the brick. Some of these additives, like manganese, have an impact on the toxicity during the production process, as well as of the waste material. And in the yellow box, there are secondary production processes like flashing or smoking of bricks, which imply extra firing cycles and generate extra CO2 release, with the only purpose of making the bricks look more rustic. And in the red circle, last but not least, there's the question of the mortar. Cement-based mortar, of course, has a higher CO2 impact than chalk mortar. For a lot of contemporary brick applications that do not simply imply stacking, the structural performance of cement mortar is often something that is counted on in terms of stability. So looking into the production process and life cycle of bricks and working with both reclaimed and new bricks, I believe that there are clearly some challenges or contradictions for contemporary brick production. And that has to do with the fact that heavier bricks that are baked on a higher temperature are stronger. They have longer lifespan and are much more suitable for reuse, but their production, of course, has a bigger ecological impact. Lower firing reduces CO2 release, but lower firing reduces the strength and lifespan. Perforated bricks require lower firing, they generate lower transportation waste, and they lower the use of resource material. But perforated bricks are not as strong and not as durable as solid bricks. They have lower resistance against deconstruction damage, lower reusability, and they are harder to clean. As you may know, Belgium, Flanders in particular, is a brick region. On the first map, you can see the geological areas that provide the resources. The second map shows all different excavation activities on the territory. Very often clay is the byproduct of other excavations. And the third map shows the location of brick factories through time. Flanders has an economy in brick production since the 13th century, in which evidently our river network played an important role. This is an overview of available reclaimed bricks on the market today. You can see a variety in modules and textures depending on the production process, and different colors, mainly yellow and red, because they are made out of local clay depending on the type of clay. All these bricks were reclaimed from deconstruction works and cleaned by hand. Like many European brick regions, construction developed from massive monowall constructions to the cavity wall, which became the predominant construction method after Second World War. The image on the left here shows a pamphlet of the Peasant Women Union called The Rural Home, which promoted the ideal of the neo-traditional rural farmhouse from the 1950s onward. Movements like these have, of course, contributed to the installation of the generic image of the brick fermet house in our built environment. It is the omnipresence of brick and the way it is intertwined with our fiscality, economy, and building culture that also contribute to the image of contemporary brick architecture as a product of poetics and craftsmanship. Even internationally, German magazines like Detail and Baunetzwoche, for instance, have recently elaborated on Belgian brick architecture and Baukultur. Anyway, during the oil crisis in the early 70s, insulation was introduced into the cavity wall as a way to save energy. The image on the left shows the basic construction method of a brick house as it was educated even to my generation in the 1990s. As you can see, with limited awareness of cold bridges and insulation leaks. 10 years ago, in 2010, it was still common practice to build 33 centimeter thick cavity wall constructions with 6 centimeters of insulation and 3 centimeters of ventilated cavity space. These were interesting times because since 2005, of course, we had EPB, energy performance regulations, and at Bluff, we were already engaged in studying the passive house concept. Here you can see a timeline from the master thesis, 30 Ways to Build a Wall, which gives a chronological overview of 30 different wall compositions that Bluff built in private houses between 2006 and 2016, with detailed information about the materials and their performance, but also about the construction cost. So somewhere along the line, we were suddenly confronted with this contradiction. The 2010 cavity wall with a 9 centimeter cavity became a passive house cavity wall with a 31 centimeter cavity space. Now, in the construction of the cavity wall, we are dependent on quite a lot of secondary structural elements to stabilize and carry the outer leaf of the wall. And anchors and facades like these simply anchors and facades carriers like these simply don't make sense if you have to bridge a 20 to 30 centimeter cavity. Moreover, for sustainability reasons, we were shifting away from rigid petroleum-based insulation panels to softer ecological insulation materials that are unable to take any pressure. Bridging these large cavity gaps makes construction more expensive, complex, and error-prone. Or try to find an efficient way to make these slabs fit around these anchors. Maybe you are familiar with Florian Nagler's research, Einfach bauen at the TU München, that starts from the same observation that building according to contemporary standards has become ridiculously complex and almost impracticable. The logical result of this is that brick is losing ground as a facade material. This later became evident in 2015 when this book was released. It is a review of 10 years of passive house construction within the Brussels capital region, and it contains only one building with brick facades, which is our DNA house. So it was our observation that the EPB calibrated legitimizing of the appearance of architecture has big impact on our built environment, as well as on our role as designers. Or to put it in Rem Koolhaas' words, the architect is losing his grip on the facade to more competent disciplines. What we see is that the industry reacts to this evolution by trying to make brickwork thinner and lighter, so you will either need more anchors to keep the stacked bricks upright, or you glue the material as wallpaper on top of something else. For us, this feels like a counterintuitive evolution, not only because we were looking for a more circular approach of the construction than to glue everything together, but also because it takes us away from the basic properties of brick, often referred to as the agency of the material. A brick is a stacking module, but also a pixel in an image, a proportion system, and a representation of continuity, education, and labor. So this is where the story of the DNA house comes in. Instead of making the brickwork thinner and lighter, we decided to explore the idea of making the brickwork thicker to make it structurally and thermally independent. Inspiration can, of course, be found in pre-cavity wall constructions, where you see that the shell is highly valued and therefore preserved and stripped down to give it a new life from the inside. Like this image of the St. Elizabeth Hospital renovation in Washington. What is equally interesting in this example is that the building is so big that the interior space can also be experienced as an exterior urban space. So this approach triggers a lot of design questions. The idea for the DNA house was to make a brick shell, a facade, as a long-term construction or a future ruin. Now, first of all, the commission for this house was quite standard, a building plot in the outskirts of Brussels, a home for a family. The cross shape of the shell enables us to work with the topography, the orientation, and the planning context, and in itself is already quite stable in different directions. Our experience from renovation projects was that the post-insulation of shells is often problematic and complex because of obstacles like structural embossments on the inside of the wall, or the construction knots where the floors are laid on the load-bearing walls. So to make sure that we would have no obstacles on the inside that would prevent us from post-insulating in an efficient way, we made the shell as flat as possible on the inside. I will just run you through these images to get an idea of the interior space. What you can see is that after finishing the shell, we put a timber frame flat roof on top that is supported by the walls. This way, the rest of the construction can take place in weather-protected conditions. Here you can also see how the foundations are going with the topography of the landscape. The shell is constructed in reclaimed machine bricks as a full stone wall construction to make it self-bearing, with a basic cross bond, which consists of altering layers of stretchers and headers. So the brickwork has the same expression on both faces of the wall, which was important to us because we knew that parts of the shell would stay visible from the interior as we finished the house. So what happened is that because of the flat treatment of the inner side of the wall, all the structural elements required for the autonomy of the shell are pushed to the outside. This is how the tectonic expression of the buttresses and beams and the cornices emerged, merely as a result of engineering of the shell. Next stage of the construction was the infill of the shell, which is a timber frame construction. What you can see in the plan is that the timber frame follows its own construction logic and rhythm with logical spans, room measurements, and enfilades. This is an image taken during the construction of the infill, and two pictures taken right after the delivery of the house. This 3D detail section of the construction of the house shows you the whole principle of the construction. With the self-bearing full stone brick wall on the outside, the first layer of semi-rigid insulation perfectly fitting the flat inner surface, and the insulated timber frame behind it. You can also notice that the sections of the timber frame are very limited. This is made possible because the brick shell protects it from the wind forces. So that's the story about the DNA house. What I want to show you next are some slides to give you a quick overview of what the DNA house has instigated in our practice. I will not go into them in detail because each one of these projects would make an extra lecture, but the DNA house has triggered the use of reclaimed bricks in other projects like this patio house or this family home where the stability of the brick shell is generated by curved shapes. We have further conceptualized the idea of the shell and the infill in renovation projects like this one. This is, by the way, the project that has won third prize in the AIT award last month. We have developed new facade brick products to make self-bearing facade constructions like we did in the DNA house in a more economic way. This is called the Bluff Big Brick. The first one was manufactured by Wienerberger for the construction of a series of experimental houses, testing different wall compositions for brick, shell, and timber frame infill constructions. The second one was manufactured by Ploegsteert and was developed for a 6-story high self-bearing balcony structure of our project at the Old Docks in Ghent. This is an urban development project, and it also has a 100% circular system for energy, heat, water, and waste, but that's also another lecture. And the third batch will be manufactured by Ploegsteert for an affordable housing project with 80 apartments in Brussels, where we are now working on the circular construction concept with cross-laminated timber, facade cases filled with hemp insulation, and a 5-story high self-bearing brick facade construction. We will also grow the hemp on site and later reuse it for the production of the insulation material. So this is for the future. So with this, I have reached the end of my presentation. Thank you for listening, and I'm looking forward to your questions and reflections.
Thank you, Lieven. It's actually quite astonishing to realize that the intensive engagement with one single project like the DNA house can lead to this fundamentally new insights concerning construction methods and influence one's whole building practice. So yeah, we have now reached the end of the presentations and still have some time for questions and answers and even a short discussion round. So I would like to encourage all of you from the audience to just feel free and ask your questions. You can therefore raise your hand within the Zoom reactions. You can find this icon in the bottom right corner of your menu. So we can see then who wants to ask a question, or if you prefer, you can also just write your question in the chat and we will then note this. And my colleague Magdalena will now guide you through this question and answer session.
Ja, thank you, Christiane. Kurz auf Deutsch. Sie können auch Ihre Fragen auf Deutsch formulieren und wir stellen die dann auf Englisch unseren Gästen vor. So thank you all for your really interesting presentations. I liked all your buildings. I think they're very advanced if it comes to circularity. And my first question would be to Lieven. What do you think is, because you talked about low tech and that the complexity grows in the building sector. For example, you showed us the problem of the anchors or composite materials. So do you consider the low tech approach as a strategy towards circularity? Does it help? Low tech is
certainly. I think there's different important fields of attention towards this this growing complexity. One of them, of course, is education. What we notice is that the education of constructors is maybe running behind, or not so much the education of young constructors, but a big part of the market is also run by older constructors who are educated like 20, 30, 40 years ago, and they are struggling. They're struggling with practicability of certain methods and the application of certain materials. So education is very important, and this is exactly also the reason why low-tech is very important. It's because on site, on a construction site, you have to be able to work with people, with constructing people who have to understand what you try to explain. So it's of major importance that architects do not sit in a tower and design highly advanced concepts that are not executable. I think it's very important to have contact with contractors. A lot of the, I showed the slide with the 30 ways to build a wall. A lot of the information there, a lot of the variations that we have tested in these 30 wall composition concepts, a lot of these variations were generated by the insights of constructors and contractors who gave us feedback like this is taking twice as long to execute this detail if I do it this way than if I do it that way. And because labor is so expensive, practicability is very, very, very important, I think.
Yeah, thank you. So as I see that communication is a big thing, and communicating information about how you construct. Mm-hmm. So my second question would be to Jos. Would you also agree that communication of your principles is an important thing? And did you also had to communicate to craftsmen while you were building your projects about did you have to teach them about new methods? Was that also a task that you had to execute?
Yeah, it's often, or occurs often in projects that we have to explain to a contractor how we want to do it, but it also works the other way around. We try to involve them early on in the process so that they can tell us how they would usually do it, and that we find a way that works for them while reusing materials, of course, because they are, more than us, the expert on how they would usually build and which techniques they have and how to deal with it this fast. And I agree with Lieven on the sort of making buildings more simple and not just on the structural part or the way that the contractors work in building it, but also on the installations that are inside and the way insulating, ventilating, making sunscreens, etc. There's sort of a tendency towards making buildings more and more machine-like to control the environments that we live in. Well, actually, we should go the other way around, making them more energy efficient by using less energy.
Yeah. So if I can get back to that communication thing. So did you use different methods to, because you said that before you took the craftsmen into, you talked to them in the very beginning. Do you do this in all your projects, that you take all the participants, all the stakeholders into the design process even? Do you include them, or?
Yeah, it's hard to say that we do it in all our projects, but yeah, I would say that we always try to include them as much as possible and as early as possible. And in that sense, most of our works are a co-creation. It's not our vision as the architect mastermind that discovered everything and put everything together. But we have an idea of where we want to go, and we need these other parties like the structural engineer and like the fire safety engineer to help us realize the building in this way. So for example, with Villa Welpelo, the steel structure is made out of reused steel. And to get this through planning permission, we had to come up with calculations to show that it was safe. And the only way to do this was to have a structural engineer calculate the whole structure with the worst type of steel that was available around the time that the textile machine was built, because there was no certificate coming with the reused steel that would show that it would be safe. So yeah, you need these structural engineers, and you need a lot of creativity in how you deal with regulation and deal with certification in a process like this.
Yeah, interesting. Mark, would you agree, or would you like to tell us some things about your obstacles during your planning process? Did you have also any regulations with the prefabricated concrete elements you were using in your building?
I think in general, when you work with circular materials, it's very hard to get the guarantees of the construction company. So you need a daring contractor to take the risks. That's for sure. So you need a lot of co-creation and a lot of teamwork. And with the regulations, for example, we had a problem because we took out a complete concrete part out of the gallery flat. When we moved it to another place and put it there, then of course it was a newly built pavilion, and the ceiling height from the former flat is not the right ceiling height for the new regulations if you build something new. So it was in fact impossible to build the pavilion like we did, because the ceiling height was not the right height in this case. And we had to be very creative, just like Jos said, and to find out how we could do it. And at the end, we convinced the municipality that this was not a new building, but it was a renovation of the apartment. And that's how we got our regulation. So it is in a total different location with a different address, but still it's the regulation form that says it's a renovated apartment and not a new building.
So I see it's a lot of effort, and it needs a lot of creativity and a good client, a good someone that is supporting you in that process. So what would you say is the main driver how to make these principles a state of the art of today's building construction?
You mean
to make it
on the regulate? I think very important is that the governments realize that if you want to reuse things, then we have to loosen some of the regulations, because otherwise it's becoming very difficult. And like Levin says, details are evolving that makes no sense anymore. So we have to get lesser regulations, I think, to really achieve something, to achieve big steps. Yeah.
Yeah, thank you. What do you think, Levin and Jos? Would you agree? Do you know any other aspects which would also support the transition towards circularity?
I think there's a very important. I was wondering if Mark's project, I think all of our experimental projects, and I think the Superuse projects that we saw were all private projects, but Mark's project was a public project. Was it also publicly tendered to a contractor? Because I think we have, anyway in Belgium, but I think in most European countries, for public commissions, you have the public tendering procedure for contractors. And there you have this rule that if you want to prescribe a certain material, you need to be sure that you should describe it anonymously, and you have to guarantee that there's at least three parties on the market who can deliver these materials. This is a big problem if you want to work super local and if you want to work with reclaimed materials. I think this is a big challenge.
Yeah, I heard that in the last session. Someone also said that they wanted to include all stakeholders from the beginning of the process, which I think is also very important in order to build circular. But we actually can't. If it's a public building, we have the same tendering process as you described it, and it's how they solved it is that they took a manufacturer, and at the end they needed to tender it out to a different person. Yeah. So Joost, do you have any other comments about that? Any other tips?
I don't know about the regulation that you have to be able to provide 3 different suppliers for a material, which of course I think could be worked around, but I agree completely that we need simpler and more clear regulation. So it should not state how to do it, but what you have to achieve. And that concerns basically everything in a building process. So if you're looking at a roof renovation, it should state that it should become sort of water retaining, and it will slowly put the water towards the system of the sewers, or it should be energy producing, or it should be collecting fine dust from the air. One of these things, or all of these things combined, but you can't get away by just putting tiles on top or putting new bitumen and do your renovation like that, because all buildings that we are going to build now and we are renovating now, we are not going to touch in the next 15 years. So basically everything that we do now should comply to the rules that we expect in 2035. And we don't know the rules, but we know the climate goals and we know the sustainable development goals. So we know where we're headed for 2030 and 2050. And that is something that we have to keep in mind, I would say, as an architecture community, not necessarily what are the rules to build a building today, but what are the rules that we expect in 10 years or 30 years from now.
Yeah, very interesting. I agree to that. We have a question from the audience, and it is, how do you find harvest secondary material, and how do you navigate warranty issues? And then, is it compulsory to avoid public authorities as clients to build circular? So 2 questions.
Yeah, I can go first. So about harvesting material, of course, we've done this over 20 years. So we have a big inventory of possible suppliers. And for example, simple things like window frames, we know that it will be available. We don't know which size. We don't know if it's wood or aluminium, what we will find. So you could also say that we're able to provide 3 suppliers if we want, so that you could do a tendering process for a glass facade of a big public building. It would be possible, but you would have to tender it first, then see who gets it, and after that design the facade, so that you design with the material that you would actually harvest. And that's also a way to navigate around those warranty issues, because with that tendering process, you could prescribe the warranty issues and say, okay, it should be double glazed or triple glazed. It should be, I don't know, stay in the same condition for at least 25 years. And that is also what we've done before with like public authorities. So together with Wessel van Geffen Architecten, we designed a recycling center in The Hague for the municipality. And they wanted warranties about the sustainability, or actually the durability of the facade, which we made out of waste metal or scrap metal. And we had to galvanize it to get the warranty issues solved. But that was fine. We designed the facade as a metal facade that could become rusty. And we are okay with changing the design or adapting the design to overcome all these warranty issues.
Thank you. Maybe Mark, you would answer the question if we need more public or authority clients so we can build more circular. So is it compulsory to avoid public authorities as clients to build circular? You had public client.
I think the important thing for a super local project is that we get a lot of funding from different institutions, and just to pay for the experiments, let's say. So in that case, I think it's very good to work with public authorities and not avoid it. And On the other hand, I think in the Rheinische Revier, it's now a big transition is announced. So we have to do a lot in the Rheinische Revier and change a lot, build circular and meet new goals. So I think we need the authorities and the government to make this possible. So I think there's a huge chance here that the government should try and cooperate and make sure that the regulations and the funding is made available.
Yeah,
Because
also
we have to develop these new strategies for the future. We cannot go on the way as we did.
I also agree to that if the government gives us new regulations, they also should test them on themselves and actually give more funding and give best practice principles of circular buildings. There's another question from my colleague Lilith.
I will just place it here by saying something. So during our consulting of projects, we come to the question sometimes that we have a project that is that has material and wants to give it away to another project, and then you have another project which wants materials, and of course, we already have companies who are trying to get this transition done. So there's some Börsen. Oh my God, I don't know the English word.
Prestado, there's, for example, company.
So you have the company Prestado, and they are trying to do that, but still you have this this problem of there is at some point there is somebody who has building material, another point there's somebody who needs material, and how did you find your material during the process? I mean, you already said it somehow, but how did you get this transition done? When did you talk to the people giving you this material? Did you go and find the material and then you said, okay, this is how we're going to do the project? Or did you start the project and then you started looking and then it had to be like kind of a timing issue on when to get the material? Maybe Joss could say something about that. I think you had this problem a lot.
Yeah, probably the simple answer is yes, because it's all true. The project starts and then you start to find material, but also you know of sources of material that will be available, and when a project starts, you can bring them into it. And for example, in the case of Kringloop Zuid, the window frames, they are actually harvested by the company that was demolishing those apartment buildings. And that was the same contractor that was going to build Kringloop Zuid. So that was not completely by accident, but we didn't know when we started the project that we would work with a contractor that would do demolition and construction of the same project. And it really helped us in that case that they, as a demolisher, in advance knew that they would have to reuse those same window frames again. Because usually when you see demolition, well, you saw it in the pictures of Mark as well, there's a wrecking ball coming in, or not a big crane that's just crushing everything. And we try to get rid of it as soon as possible. Actually, we should move away from demolition and go towards deconstruction. Just like we do construction, we do deconstruction, we take the elements that we can use. And I'm really, I love the project of cutting a whole fragment of a building, and that you were able to make that a renovation project, so to say. And then I'm wondering, where does that start or end? So at what point do you still call it a renovation? How far away can you move that piece of structure? Or if you would just cut slabs, floors, walls, and reuse those floors and walls in another configuration, could you still call it renovation? So that's a really interesting approach to bend the rules that we have now to experiment with more circular projects.
Maybe I just to ask the other two as well. I mean, you worked as well with reused materials. Did you do it the same way, or did you have a completely different approach? I mean, you used the bricks. You used Niels, I think you used them every time, as I understood. So maybe you had the constructor already who gave you, or you already had the source, or how did it work?
We wanted to make. We knew we wanted to make a brick house. That was the only thing we knew, and then we started looking for the right bricks for the house, and then by contacting. The funny thing is, it had been over 10 years since we designed a brick house. So we decided to go and look into the whole production process and into the whole history of brick and into the whole market to find out if we had to do a brick house after 10 years, what kind of brick would we like to use? And then that's when we found out that these old bricks, they are much stronger, and of course the reuse of this material has a huge impact on the footprint of a project. So so we contacted a local dealer, and he delivered the reclaimed bricks, nicely palleted for the project. Of course, for a house, this is not a problem, but if you have to do much bigger projects or public projects, you have to make sure that you can keep the flow coming for the supply of the materials. So we know now in Flanders there are some suppliers who devoted a piece of their activity to reclaiming bricks and repalleting them and cleaning them and reselling them. So it's starting to grow, but at first it was very small scale. Which is also something that we were not the first to come up with the idea of reusing reclaimed bricks. This is something that has been going on forever in Flemish DIY building culture. Everybody builds a garden shed with the bricks that he reclaimed from an old garage or from his uncle's old shed or whatever. So, but the upscaling of the whole concept requires a lot more organization and a lot more tools and inventories and I'm not sure. I don't know how this is in Germany or in the Netherlands right now, but in Flanders we are only starting to realize what it takes.
Thank you, Lieven. We have Dominic here from Concula, who is actually working at a company that is doing the so-called matchmaking platform. Maybe Dominic, you want to say something about Restado shortly?
Sure, I can do. Thank you. So I mean, they are like the concepts which are also presented, for example, the harvest map in the Netherlands. We have like a similar concept, a bit different, which is called Restado, which is a marketplace for reclaimed construction materials. So there we also, for example, sell a lot of the reclaimed bricks, which are coming from projects all over Germany, but also, for example, old wood and windows and so on. But like what we created also in the last year is Concula, which is then really trying actually to address the challenges which were mentioned here, like going very soon into deconstruction projects, identifying what materials are in this building by digitalizing these buildings, and then bringing that into new projects by connecting architecture offices on the other side. So what we are doing is really giving architecture offices access on our software. They upload the material demands. They can also browse on like a material list, and hopefully can find the materials already in the planning phase, which was also mentioned, which is important, is that as soon as possible, these materials can be found. And if they find it, we can then take care about all the process in between. So recertification, ensuring the quality, refurbishment, warranty, and so on. So with that, we really want to bring like this circularity idea into large projects.
Yeah, thank you. Thanks, Dominic, for jumping in.
Can I react to that?
Sure.
Because this is of course very interesting, and it's much like we have pioneers in Belgium. They are called Rotor. Maybe you heard of them. They have 3 activities within one company. One of them is like the deconstructing of buildings. The other one is they work as an architecture office and as a research practice as well. And then they also founded Opalis, which is a platform where you can find resold reclaimed materials. But these are interesting practices, but hopefully in the future more of these practices will emerge. And then my question is, how will these practices get interconnected and work together, and then start connecting their databases or work as an open source conglomerate? I don't know. Is there a model for this? I mean, this should be because of course the market for reclaimed materials should not be in the hands of 1 or 2 or 5 companies, I suppose, in the future.
Yeah. I mean, it's still a regional thing. I mean, you wouldn't transport one brick from Belgium maybe to, I don't know, somewhere else too far away. So it's still a regional market. So we've got another question from a person from the municipality administration. And first of all, the person loved the presentations. So did I. And the question is, how do we come from pioneering pilot projects to circular economy practice? Is there, for example, a measurable effect if there's reports on sustainable projects in architectural magazines, or inviting architectural and engineering association to the construction site? So is that any strategy to promote circularity, or do you have any other strategies that would come or move your project as being pilot project to more state-of-the-art projects? I think that's the question here.
Yeah, I would not consider most of our projects pilot projects anymore, because, well, I sort of have difficulties with the idea of a pilot project, because it means that you do something once and then you evaluate 5 years later, and then you take conclusions, and it takes architecture, or the building industry is already a slow profession. So changes take a long time, building projects take a long time, and innovation takes a long time. And I don't know if it was said here today or somewhere else, but the idea that basically every project that we do is with another architect, another client, another contractor. And you could say that every project is a pilot project, or that is just the building profession, that we do a lot of projects and we innovate all the time. And we learn from all of what we see, not just that we do ourselves, but also that other companies do. And sessions like this and exhibitions like the ones we have coming up in München and Berlin and Austria, they help to spread that message. And I think that slowly changing the, let's say, the discussion or the argument about what is good architecture and what is bad architecture, what is sustainable architecture, and what that will help to move towards a different kind of legislation and a different kind of architecture. So it's mainly the way we talk about it right now here, and the fact that we talk about these 3 or 4 projects more than that we talk about, let's say, the well, any kind of standard new building that could also be really nice and can also be in front of a magazine, but it's not necessarily sustainable. So they are not invited.
Yeah, I agree. So yeah, that's what is also our job, like to talk about it and spread ideas and information. So maybe I just finished the question because the person also asked if the public administration could also promote the demand for recycled materials, and if that is a good idea. Yeah, of course. I would say so. What do you think? That to promote recycled materials from public administration, is that a good idea to move towards circularity or circular economy?
Yeah, well, if I can go again, Mark Lieven. I'd say it's part of the task of local authorities or national authorities as well, that they do their spendings in the way that they want, where they want to move towards. And what I always find interesting is that at some point, a project manager or someone will come in and say, yeah, it's too expensive, or it's becoming more expensive than the traditional way of doing things. And that's the point where you have a discussion about, okay, what can it cost, or is it publicly feasible to spend more money on a more sustainable project? And you could go, let's say the financial argument is, no, it's not publicly feasible to do that. But you could also reverse that argument and say it's publicly necessary to do that, because it's public money. You have to spend it in a way that it will last for generations, instead of making a financial gain right now. Because municipalities and countries, they are in it for the long run. They are going to be here in decades, centuries, etc. At least that's what I expect and hope. So they can make decisions based on 50-year goals or 100-year goals instead of short-term economic goals. And that's different than compared to, let's say, the snack bar around the corner selling fries, which have a short-term goal at first to sustain themselves.
Yeah. Thank you. So you talked about costs. So the next question would consider that. So it is, how do you calculate your design your buildings? How do you include residual value, for example, and how do you measure it in order to convince maybe a client that is not on board yet with implementing circularity? How do you consider costs?
Maybe I can
please
say something about the pavilion. So as you saw, we cut out 3 huge concrete elements out of the gallery flat. We used a huge crane for that, and we transported it. So it was very, very, very expensive. And you cannot convince anybody to do that if you look at the costs of it. So if we would just have built the concrete walls on site, maybe it would have cost like 40,000 euros, and now maybe it was 200,000 euros to build this pavilion in this way. So it is, yeah, it's hard to convince if there's no budget. But I think it's necessary to do these experiments to see if it's possible to reuse material in this way. And in the future, maybe it's the only way to do it. And then we're not talking about costs anymore, then it's just the way that we have to do it. So in this beginning, the costs are very high, and I think it's difficult to do it in a cheap way, these experiments.
So if it's not cost, so maybe you have other factors how to measure your benefit from circular constructions.
Well, what we did, we just made a very high ambition. The question was, is it possible to make a new building from material that's on this site, on this local area, and just make it 100% reused? And then I think we found out that it's not possible. So by coming up with this crazy ambition, yeah, that was the rule. So we tested it in that way. But I think it makes no sense to reuse an old installation for energy saving. You need a new one, and you need if you have a building from the 60s, there's no insulation in it. We need insulation, so we have to add it. So you can. It's very hard to do it 100% reused from the local site. Of course, there are other ways to come up with good insulation that's maybe reused, but not on that side. So yeah, it's experiments.
Yes.
Super. If I may go into that a little bit further, maybe, or react to that.
Yeah, we're a bit running out of time, but yeah.
Okay.
Sure.
Well,
Go.
it's interesting. So we don't have limited time. From a different context, maybe, Mark. For us, we are just an architecture office with. We work from our own practice, so we don't have any funding from the government to do research or things like these. We work for the DNA house, for instance, is a very small building for a private client. So the budget is indeed an argument. I think we calculated 3 or 4 different construction methods to collect the arguments and talk with the client about which one would be more suitable, and also to talk about the costs, and to every cost that you have extra for the use of a certain construction method should be compensated, at least in the case of the DNA house. And for small private commissions, we are often not forced, but we are often asked to compensate. You have a budget, and if you want to work within the budget, but we believe that in the long run, of course, if you make radical choices, it's much easier to work within a budget than if you have an idea and then you have to make compromises and do a bit of everything. So it often has to do a bit with how radical you want to think as a designer. And then for the Brussels project, and I'm very, very curious, because we are now in the phase of making these calculations of the construction method and what would be the cost and what would be the benefit on the long run, because this is a building with 80 apartments and it will be in the hands of one owner for 30 years. So he has to maintain the building. So he has much more costs over a span of 30 years that he has to put into account. But there's no such thing. We are doing this together with the developer and with the contractor at this moment, but there's no standard calculation tool to do this, I believe. So if you have methods to simulate these long-term costs and benefits of a project over 30 years, I'm very curious to learn about them.
Thank you.
Yeah, I agree. It's very difficult to calculate in this stage if you work like this. But also the scale is very important. So if you work for a single house, the budget is different. And if you use a crane like we did, and we would harvest from one apartment block 300 units like we did, then of course it would be very cheap. But now we only harvest 3 of them. So scale is very important to make this work. So I think in the whole circular economy, it works when everybody is joining.
Thank you. So does anybody want to join in anymore, say something, and add to that? If not, I think we could wrap it up. Maybe Christiane Can you wrap it up a bit for us?
Yeah, thanks again to all speakers and also to all participants of the webinar so far. And yeah, I think we've seen 3 great examples on how we can build in a circular way and how we can use less primary material and how to use waste as a resource. And in the future, I think we should think on how we can reuse this material again and again. That's also a topic which we will have on our agenda in 2 weeks in our next webinar. Yeah, for today, I think we got a lot of new inspirations of how we can build according to circular economy, but we also learned about the effort behind that work, which is something which is also always very interesting, not only to hear about the good sides of every project, but also about the obstacles and the certain efforts, because yeah, that's actually the part where we learn the most. And yeah, I think there's still a lot of knowledge transfer to made, and therefore I want to thank all your presentations and for all your contributions today. And I would like to kindly invite you to our next webinar in exactly 2 weeks on the 4th of March, again a Thursday, and again at 5 p.m. in the same room here on Zoom. And Magda, would you like to add something, or?
No, I think yeah, we've all done a good job today to talk about problems, but also show solutions for that. And I think we try to answer all the questions. There's still a lot we need to do, make the transfer to circular economy, but I think we're in a good way if we continue talking about it. Yeah. Thanks, Christiane, and thanks to all the speakers.
Yeah. Thanks, and stay safe, and hope to see you soon again, and in 2 weeks in our next webinar. So have a nice evening, everyone.
Bye.
Have a nice evening.
Nice evening.
Bye.
Goodbye.